Hello learner, I am Dr. Purnima Tiwari, Assistant Professor of Mathematics, the Bhopal School of Social Sciences. In this video lecture, you are going to learn about gradient of a scalar function. Scalar function is a function that associates a number or a scalar to every point of the space. Let us start with the definition of gradient of a scalar function. Gradient of a scalar function is a vector quantity, that is a vector function, directed towards in the direction of fastest increase of the function. We can find gradient whenever the function is given in the Cartesian form as well as for the polar form. If f of x, y, z be the given Cartesian function and del is a vector operator. This vector operator del is also called nebula and its value is I cap del by del x plus j cap del by del y plus k cap del by del z. Del by del x, del by del y and del by del z are partial derivatives with respect to x, y and z respectively. When we apply this del operator for this function f, we get gradient of f, and gradient of this function is denoted by grade f. Value of the grade f is del dot f. Now, we will write the value of del, that is I cap del by del x plus j cap del by del y plus k cap del by del z. And to this vector operator, we will operate our Cartesian function f. That is, we will get I cap del f by del x plus j cap del f by del y plus k cap del f by del z. This deal like a formula to calculate gradient of a scalar function f. There are some properties for gradient of a function. If we calculate gradient of a constant function, we get this value as 0. That is, if this function f of x, y, z is constant, say k, then the value of gradient of f is 0. Reason is, if f is constant function, del f by del x is 0, likewise del f by del y is 0 and del f by del z is 0. When we substitute value of these partial derivatives as 0, we will get gradient of the function f is 0. Now, the second property is for gradient of sum of two functions. Suppose two scalar functions are f of x, y, z and g of x, y, z. And we have to find gradient of their sum, that is f plus g. So, we will write grade of f plus g. And the value of grade of f plus g is grade f plus grade g. Likewise, we can find gradient of f minus g, that is grade f minus g, and this value is grade f minus grade g. If we have to find gradient of product of two function, that is grade of f into g. This value is f grade g plus g grade f. It is in line with the product of derivative of two functions. Likewise, if we have to find gradient of quotient of two function, that is grade f by g. It is also in line with the quotient of derivative of quotient of the function, that is this would be g grade f minus f grade g by g square, and this is true only in the case when this function is non-zero. Next we will solve one example where we will find gradient of this function f of x y z, which is x square plus y square. We will apply the formula gradient of f is del dot f, and this value is I cap del f by del x plus j cap del f by del y plus k cap del f by del z. Now see, the function f is x square plus y square. To get del f by del x, we have to differentiate this function partially with respect to x. That is, we will differentiate x square, will get 2x. Now, when we differentiate partially with respect to x, this y will deal like a constant and this value will be 0. That is, del f by del x is 2x. Now, we will differentiate this function f partially with respect to y. When we differentiate partially with respect to y, this x square will deal like a constant, that is its differentiation is 0, and partial differentiation of y square will give 2y. So, this term is 2y. Now, next we will find partial differentiation of f with respect to z. So, x and y both will deal like constant, therefore, del f by del z is 0. Now, we will substitute the values of del f by del x, del f by del y and del f by del z in our formula. So, we will get 2x I cap plus 2y j cap plus 0 k cap. That is, gradient of this given function f is 2x I cap plus 2y j cap. That is our answer. In the next example, we will find gradient of this function x square y plus y square z plus z square at the given points 1, minus 1 or 0. So, our function f is x square y plus y square z plus z square. First, we will find all partial derivatives, that is del f by del x, del f by del y and del f by del z. So, to get del f by del x, we will differentiate this value partially. We will differentiate x square will get 2x, and as we are doing partial differentiation, this y will as it is. When we differentiate y square z partially with respect to x, the both will deal like a constant. So, this differentiation is 0, and when we differentiate z square partially with respect to x, this differentiation is also 0. That means, the value of del f by del x is 2xy. Next, we will differentiate f partially with respect to y. When we differentiate with respect to y, this x square will deal like a constant and differentiation of y will be 1. Plus, Here we will get differentiation of y square is 2y, z as it is. Partial differentiation of z square with respect to y is 0. And when we get del f by del z, this will deal like a constant. So, it is 0. When we differentiate this, we will get y square, and when we differentiate the last term, we will get 2z. When we have to find gradient, we will substitute these values in the formula. That is, grade f is del dot f, and this is I cap del f by del x plus j cap del f by del y plus k cap del f by del z. Now, on substituting the values, we will get I cap del f by del x is 2xy plus j cap, del f by del y is x square plus 2yz plus k cap del f by del z is y square plus 2z. So, we can write it as grade f is 2xy I cap plus x square plus 2yz j cap plus y square plus 2z k cap. This is the value of gradient. But in this question, we have to find gradient at the point 1 minus 1 and 0. That is, in the obtained value of gradient, we will substitute this value as x, that is x equal to 1, y equal to minus 1 and z equal to 0. So, we will get 2 into 1 into minus 1 of I cap, x is 1, y is minus 1, plus 1 square plus 2 into minus 1 into 0 j cap, x is 1, y is minus 1, z is 0, plus y square, that is minus 1 square, plus 2z 2 into 0 of k cap. Now, we will solve this. So, we will get grade f at the points 1, minus 1 or 0. First value is minus 2 I cap. Now, here this second term is 0, 1 plus 0 is 1. So, plus j cap plus. Here second term is 0 and first term is minus 1 square, that is plus 1 k cap. This is our answer. You may solve some more examples to find gradient of a scalar function at given points. Thank you so much.